MODO Morsels.
Have you ever wondered if you are inside or outside? Probably not. It's really obvious, but how do you know? In this morsel I will look at how to use MODO's intersection constraints to determine whether a point in space is inside or outside of a mesh. We will use two tools for this job: surface intersection and direction constraint. Let's review what they do and how they work. If you are not familiar with constraints, you can find them in the animation controls under the Constraints tab. First up is the direction constraint. Select the item that you want to constrain, then the item that you want it to point at, and press the direction constraint button. If I now move either of the items, the constrained item remains pointing at the target. Very handy, for example, if you want a camera to track a target. Let's open up the schematic to take a quick look at what's been set up for us. It's always good to know what's happening under the hood. The direction constraint takes a position from the pointer and the target locators and outputs a rotation which is fed into the pointer's rotation channel. Next up is the intersection constraint. By default, this finds the closest point on a surface to a given probe item. It creates a locator at that point. First select the probe and then the mesh and press the surface intersection button. Notice how the new locator is always on the target surface at the nearest point, irrespective of whether we are inside or outside of the mesh. This is going to be important. Let's quickly look at the schematic. The intersect constraint is connected to the target mesh and its combined transformation. The position and rotation transforms of the probe are also fed in. The result of the intersection is a position which goes into the locator. There is also a distance channel which tells us how far away the surface is. The intersection constraint can operate in another mode called ray. Rather than compute the closest point, it shoots a ray from an item in a given direction and puts a locator at the intersection point, if any. If it misses, the locator remains at the origin of the ray and the distance result is 0. Note that when we are inside, the rays do not intersect the back faces of the mesh, but they can potentially intersect with other parts of the mesh because this is not a convex shape. This too is very important to our plans. So, what is our strategy? Do I even have one? Let's do some thinking. A dangerous pastime, I know. Consider a sphere. If we have a point outside and find the closest point, then casting a ray in the same direction, we should hit again, because the surface is front-facing. Conversely, if we are inside, then casting a ray at the closest point will not hit the surface, because the ray intersection does not hit back faces. So just checking for a non-zero distance on the ray intersection might work, but hold on. Consider instead a torus. Casting a ray at the closest point, we can still hit part of the surface even when we are inside. Calamity! But there is a difference. The key observation is that the distance to the closest point and to the ray intersection will be different in this case. So we can use the difference of distances to spot when we are outside, when the distance should be the same, or inside, when the distances will be different. Putting this all together, can we create a network of nodes that calculates whether we are inside or outside of a surface? Of course we can. Deep breaths. First select the probe and then the mesh and select Surface Intersection. We now have a locator at the nearest point on the mesh. Create a new locator and parent it to the probe using Control Drag. We will point this locator at the closest point using a direction constraint. See how the blue or Z axis of the locator is always pointing at the locator on the surface. Next, create another surface intersection from our new locator to the torus and change its type to ray. This creates yet another locator, which we can't see because it's coincident with the locator already on the mesh, because, well, we're outside. Let's see what we've got in the schematic view. Just a bit of node shuffling. To check for inside or outside, we need to test if the two intersection distances are the same. Add an A equal to B logic node and feed in the two distances. I'm going to use the output channel to drive a display rig I prepared earlier to test that this all works. In this case, I want to output 1 for the true result, which will correspond to outside, and 2 for a false result, which means inside. Connecting it up, we see that we are currently outside, no surprises, and moving the probe around confirms that it all works. Well, all these locators are a bit annoying and we don't really need them, so let's remove them all. This locator is just forwarding the rotation. Gone. And this one is passing on a position. Gone. This locator is not being used at all. Gone. The final locator is the one parented to the probe, so its world position is the same as the probe's world position. So let's use that instead. Gone. And we are good to go. Or we would be if I wasn't so fussy. I've just moved stuff around and done some renaming and added some elbows to make the schematic easier to read. And there you have it. You can now test whether you're inside or outside of an arbitrary mesh.